In this video, let's differentiate hyperbolic functions. First, we have hyperbolic sine and we want to find its derivative. By definition, hyperbolic sine is e to the power x minus e to the power minus x whole divided by 2. So 1 over 2 is multiplied with this one. 1 over 2 is constant. We can take it outside of the derivative. So this is just derivative of e to the power x minus e to the power minus x. Derivative of two functions subtracted is the subtraction of individual derivatives. So we have half derivative of e to the power x minus derivative of e to the power minus x. What is this one? This one is e to the power x. Derivative of x, e to the power x is e to the power x. Here we will apply chain rule. Derivative of e to the power minus x is e to the power minus x, then derivative of minus x, which is minus 1. So we have e to the power x, this minus minus multiplied, this becomes plus e to the power minus x whole divided by 2. So this is cosine hyperbolic x. So derivative of hyperbolic sine is hyperbolic cosine. Next we have the derivative of hyperbolic cosine. By definition, it is e to the power x plus e to the power minus x by 2. This is our cosine hyperbolic. 1 by 2 comes outside, then derivative of, let us write directly, e to the power x plus derivative of e to the power minus x. What is derivative of e to the power x? It is simply e to the power x. Derivative of e to the power minus x, again chain rule. This is minus 1. Derivative of minus x is minus 1. So this becomes e to the power x plus minus minus, this is e to the power minus x whole divided by 2, which is hyperbolic sine. So derivative of hyperbolic cosine is hyperbolic sine. But in trigonometry, derivative of cosine is minus sine. Note this thing. Next, let's find the derivative of hyperbolic tangent. By definition, what is hyperbolic tangent? It is hyperbolic sine over hyperbolic cosine. Here we can apply the quotient rule of differentiation. What quotient rule says? Quotient rule, if we are finding derivative of function f over g, then this is, in bottom we have g square, g times derivative of f minus f times derivative of g. This is our quotient rule. So here we have g, this is f, g square, hyperbolic cosine square. In numerator we have this one, cosine hyperbolic, times the derivative of hyperbolic sine, which we have seen, hyperbolic cosine, this is hyperbolic cosine, minus, next the derivative of this one, or the hyperbolic sine, times derivative of this one, derivative of hyperbolic cosine is sine hyperbolic. So we have hyperbolic cosine square minus hyperbolic sine square x divided by hyperbolic cosine square. So by hyperbolic identity, this becomes 1. Hyperbolic cosine square minus hyperbolic sine square is 1. This is cosine hyperbolic square x, which is secant hyperbolic square x. So the derivative of hyperbolic tangent is hyperbolic secant square x. Next we have the derivative of hyperbolic cosecant. By definition, hyperbolic cosecant is 1 over hyperbolic sine. Again we can apply the quotient rule of differentiation, which says square of denominator, hyperbolic sine square, then keep the denominator derivative of numerator. Derivative of a constant is 0, so derivative of 1 is also 0. Then we have negative sign. 1 numerator times derivative of denominator. What is derivative of hyperbolic sign? We have already seen it is hyperbolic cosine. So this is 0 minus hyperbolic cosine over hyperbolic. This is 0, so we are left with this one. We can also write this one as in denominator we have hyperbolic sine times hyperbolic sine, because this is square. This can be written as hyperbolic cotangent, and we have 1 over hyperbolic sine, which is hyperbolic cosecant. So derivative of hyperbolic cosecant is minus hyperbolic cotangent times hyperbolic cosecant. The derivative of other two hyperbolic functions you can find in this way. So collect all the derivatives in a single frame. So we have derivative of hyperbolic sine, which is hyperbolic cosine, derivative of hyperbolic cosine, not negative, only hyperbolic sine, derivative of hyperbolic tangent, this is hyperbolic secant square, derivative of hyperbolic cosecant is minus hyperbolic cotangent x cosecant cosec x. Fifth, the derivative of hyperbolic secant, you can verify this one as minus hyperbolic tan times hyperbolic sec. Last, the derivative of hyperbolic cotangent is minus hyperbolic cosec square. The first three derivatives are positive, last three derivatives are negative, and you can see that the terms hyperbolic functions are same corresponding to trigonometry. In trigonometry we have derivative of suppose say tan x, that is x square x. All these terms are corresponding analogously same, but the signs are positive and negative. For first three it is positive and last three it is negative. Now we are ready to find derivatives of functions involving hyperbolic functions. Suppose we have, or it is given, find the derivative of ln hyperbolic tangent. Here we will apply the chain rule. Outer function is logarithm, inner is hyperbolic tangent, so derivative of logarithm is 1 over the variable inside logarithm, which is hyperbolic tangent, then the derivative of hyperbolic tangent multiplied. So this is 1 over hyperbolic tangent times, what is this derivative? We have seen this is hyperbolic secant square. So what is this one? You may simplify further, or you may only write hyperbolic secant square over hyperbolic tangent. So the derivative of this function is this one. Next, let's find the derivative of hyperbolic cosine. Inside let it be x square. So this is simply 2x times hyperbolic sine x square. Let's solve another. Suppose we have find the derivative of hyperbolic cosine x times hyperbolic sine, let's say. We can apply the product rule. It says keep the first function, then derivative of second. Derivative of second is cosine hyperbolic x, derivative of sine is cosine in hyperbolic, then plus derivative of first, which is hyperbolic sine, then keep the second as it is. We are using the product rule. This is hyperbolic cosine square plus hyperbolic sine square. So this is not 1 in hyperbolic. If here is minus, then we can write it as 1.